Hey guys, wanted to make this video about how to use the rational roots theorem to solve an equation like this one you see here. P of x equals x to the fourth plus x cubed plus 2x minus 4. Now we are going to be getting the possible roots first, and then we're going to try out some of those possibilities, and then from there we will actually be able to solve for x. Alright, so let's go ahead and get started. First off, the rational roots theorem says that if you take all of the divisors of your last number divided by all of the divisors of your first coefficient, then that is all of the possible rational roots. It doesn't mean that you find all of the roots for sure, but these are the possible roots that you'll see. So let's go ahead and get started. So negative 4 divides by 1, 2, and 4. Now the coefficient of x to the fourth is just 1. Alright? 1 just divides by 1, and that's pretty much it. So let's go ahead and start listing out all of our possibilities. Our possibilities are the divisors of the last number divided by the divisors of the coefficient of the first term. So we have positive and negative 1 over 1. 1 divided by 1. Alright, then we have positive and negative 2 divided by 1. And then finally we have positive and negative 4 divided by 1. You always have the positive and negative versions of each one. Alright, so now we have our list of possibilities. Now that we have our possibilities, let's go ahead and start dividing by these possibilities. These are possible roots. Now I'm going to use synthetic division, which is a very quick way to divide this equation by what we call linear factors. So let's take a look and see if x minus 1 is a linear factor. Now, when you take x minus 1 and set it equal to 0 and solve for x, this leaves you with x equals positive 1. So in my synthetic division setup, I'm going to put a positive 1 in, and that's going to represent the linear factor x minus 1. Now, with synthetic division, we list out just our coefficients. So we have 1x to the fourth. So I'm just going to write a 1. We have 1x cubed. So I'm just going to write a 1. Notice that we're missing the x squared term. So just so that I have a placeholder, I'm going to write a 0, which represents 0x squared. And then I will write a 2 for 2x and a negative 4 for my constant term. All right? Now with synthetic division, I'm just going to drop my first number. So take your 1 and drop it. And now we times. 1 times 1 is 1. 1 plus 1 is 2. We always add those. All right? Everything down here we times. 2 times 1 is 2. Everything up here we add. 0 plus 2 is 2. 2 times 1 is 2. Again, we add. 2 plus 2 is 4. 4 times 1 is 4. Look at that. Now, the last term, the last number that you get is always your remainder. All right? Whenever you get a remainder of 0, that means this is an actual factor. And so we can actually rewrite this as x minus 1, because we found out that x minus 1 is a linear factor, times whatever comes out of our synthetic division. So this represents x cubed. Let's try that again. X cubed. Again, you always drop your power by 1 when you divide by a linear factor. So x cubed plus 2x squared. Clean that up a little bit. Plus 2x plus 4. All right. Now from here we can actually go ahead and continue. The cool thing is that this will divide by the same factors as this will. All right, so if you want to change your synthetic division, got my rag down here on the floor. So I'm going to change my synthetic division over to these coefficients now. And I'm going to keep my same list of possibilities. All right. Let's just rewrite our synthetic division setup. Again, using the coefficients of our quotient, the thing that came out of our synthetic division. So we have 1x cubed plus 2x squared plus 2x plus 4. All right. So I've got a positive 1, a positive 2, another positive 2, and a positive 4. All right, let's go ahead and run it through. Now notice that I did not yet change this number. All right. I'm going to go ahead and see if I have a repeated factor of x minus 1, just to check it out and see. Synthetic division is so fast that you can check things out and not waste a lot of time. So drop my first number. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. Not looking good. 5 times 1 is 5. 4 plus 5 is 9. And 9 obviously is not 0. So since I got a non-zero remainder, this is not a factor. Let's try negative 1. Now, if I put a negative 1 inside the box, this is going to represent the linear factor x plus 1. All right? So let's just put a negative sign in front of it and just go through the process again. Drop your first term. 1 times negative 1 is negative 1. 2 minus 1 is 1. 1 times negative 1 is negative 1. 2 minus 1 is 1. And 1 times negative 1 is negative 1. Unfortunately, 4 minus 1 is not 0. It's 3. So I have a non-zero remainder again. Let's try one of our other possibilities. Can't keep my rag off the floor. All right. So keep your same coefficients. It's the beauty of synthetic division. If you have a whiteboard to work on, this works really well. If you don't, you're going to be using your eraser a lot. Or just write another set of synthetic division. Anyway, let's try another factor. So the next one on our list was positive 2 over 1 or negative 2 over 1. Let's try positive 2. All right, this will represent the linear factor x minus 2. Okay, drop your first term and retimes. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. 2 plus 8 is 10. Oh, not looking good. 10 times 2 is 20. And 4 plus 20, not 0. It's 24. So that didn't work. Again, we'll just keep this nice, fast pace going. And let's make it a negative 2. Okay, drop your first term. 1 times negative 2 is negative 2. 2 minus 2 is 0. 0 times negative 2 is 0. 2 plus 0 is 2. 2 times negative 2 is negative 4. We found one, ladies and gentlemen. Let me just check my work to be sure. Let's see, 1 times negative 2, 0, another 0. Yes, this is actually a factor. So here's what we now know. We now know that it's x minus 1 times the linear factor that we just found. Now negative 2 represents x plus 2, the linear factor x plus 2. And then the rest of it is what comes out of here. We have 1x squared plus 0x plus 2. Remainder 0, so we don't have to worry about that. So x squared plus 0x means I don't have to write in an x term, plus 2. All right, now we are finding x-intercepts, so I'm going to take a second and set this equal to 0. So we have really 3 simple equations. Using the zero product property, we say x minus 1 equals 0, x plus 2 equals 0, and x squared plus 2 equals 0. So I'm just going to do that over here in black so it doesn't get mixed up with our work in pink. Again, x minus 1 equals 0. Solving for x, we get x equals 1. All right, here we have x plus 2 equals 0, our second factor. Solving for x, we get x equals negative 2. All right, last factor, x squared plus 2 equals 0. This is going to take a little bit more work. All right, we got a glare right here, so I hope that's not causing the picture to be messed up in any way. Anyway, so subtract 2, subtract 2. In other words, subtract 2 from both sides, and then get x squared equals negative 2. All right, how do you unsquare x squared? Square roots will unsquare x squared, so why don't we square root both sides? All right, the square root of x squared is simply x. Now remember your plus and minus sign whenever you take the square root of something. So this becomes the square root of 2i. All right. Okay, so here we have it. 3 solutions. X equals 1, x equals negative 2, and x equals positive and negative root 2i. I hope that has helped you guys out with how to use the rational roots theorem to, first of all, get a list of all of the possible roots. Again, this is not a list of the actual roots, it's just a list of the possibilities. And we found out that 2 of these things were very good possibilities because they actually represented linear factors. All right, once we found our factors, we could then line up basically take this and put it into packages. So we took this, we got it to here, and then we took this and broke it up into 2 more packages, which then we could pretty easily break down into roots. All right, then we set each little package equal to 0 separately using the zero product property. And then, of course, we solved for x. So 4 solutions. X equals 1, x equals negative 2, and x equals positive and negative root 2i. There are two solutions locked in this one. X equals positive root 2i, and x equals negative root 2i. Once again, I hope that helps you out. I appreciate all the hard work that you guys have been doing. Again, don't worry about frustration, confusion, because enlightenment happens right after frustration and confusion. Again, thanks a lot, guys. I hope this has been helpful for you. See ya.